A few more examples that I want to cover here in section 1.3. Let's kind of put together what we already defined in the ending of the last video and talking about increasing and decreasing, and let's look at a graph and see what we can do with that. So if you're looking at this graph over here on the right, the first thing I want to look for is where are the increasing intervals. Remember, when you're looking for the increasing intervals, you're looking to where the slope is positive. So I'm going to look at the graph over here and I want to see where do I have a positive slope. You can see that it's increasing in this region, and then it begins to decrease, and then right here it becomes to increase again. So then we're going to write this using our interval notation, and since you notice that these have arrows on the graph here, this means it's going to infinity, and we're going to say, switch colors here, negative infinity to, let's grab this value right here, which is negative 2, union with, we're going to start here from this value, I'm just looking at this x, 2 to positive infinity. And so this would be your interval notation of where the graph is increasing. Now take note, you always use parentheses when you're doing your increasing or decreasing. You're not going to use your square brackets, because at the point where it changes, it's no longer increasing. Also note that the values that we're using were x values, and that we got that negative 2 from right here. We got that positive 2 from right here, just aligning with right here where it began to increase again, or aligning right here where it began to decrease. And so if we want to look at where it is at a decreasing interval, remember this is where your slope is negative. You read a graph from left to right just like you read a book. And so where is that slope negative? This area right in here. So again, we're going to use parentheses, we're going to use interval notation, and we're going to use x values. So this would be from negative 2 to 2, and that would be the interval notation of where your graph is decreasing. So sorry for the colors, just kind of color code there to kind of show you that information. Now it asks, where is a local maximum? So just kind of a remembrance here, when you're looking at the local maximum, this is going to be a y value. And so where's the maximum? The maximum is occurring right here, and that is at the point negative 2, 16. So we say we have a local maximum of 16 at x equals negative 2. And I'm wording it just like this because this is what you're also going to see as you go in and do your homework. Now it says where's the local minimum? So you'll notice it's right here, and that minimum is at the value of positive 2, negative 16. So we would say that there's a local minimum. Remember, this is a y value that we're going to grab. Local minimum at of negative 16 at x equals positive 2. And so look from the graph. I know it looks a little crazy now, but looking at the graph, we can pull data of where is it increasing, where is it decreasing. Remember, those are going to be x values. Where's the local maximum minimum? That's your y value, so of 16 at that x to be negative 2. So that's looking at one graph, but let's do another example real quick, and let's look at analyzing the following graphs. And so as we look at these following graphs, here's the questions that I want to consider as I look at them. I'm going to say, okay, let's do the same thing. Let's look at where they're increasing and where they're decreasing, and let's look at their local maximums and minimums. And so just like we did before, I want to take and I want to look at where is it increasing. And so you can see on this first graph, starting from here up into here, pick a better color this time, we've got some increasing. Starting from here and moving up, I'm increasing. You can see from infinity, negative infinity, all the way down to here, I was decreasing, and then I have a slight decrease right here. So I'm going to put that information together. So let's say, where is this one increasing? Where is it decreasing? I'm just going to abbreviate. It's going to be the interval notation using your x values. So where is it increasing? We are increasing from 1 to 3. Always use parentheses. Union with from 4 to positive infinity. And again, that was just that yellow part that we highlighted. Then a decreasing was the green part that we highlighted. So if you look at that, it's decreasing the green. Remember, this right here is an arrow. And so that would be negative infinity to 1, union with 3 to 4. And you can see that since this is a function on all real numbers, we've encompassed all of the values between negative infinity to infinity, but we've broken them apart into our increasing and decreasing. Now let's find some minimums and maximum. So you notice here, you're going to have a minimum. You notice here, you're going to have a minimum. You notice here, you're going to have a maximum. And at those 3 points, you can also see those are kind of the changing points of where your increasing and decreasing is changing over. And so we would say we have a local max of 1 at x equal to 3. And you could say that we have a local min of negative 1 at x equal to 1, pulling that first one. And then we also have another local min of minimum of let's see that second one, it's about at a half at x equals 4. And so just kind of note that wording there, a half or 3/4 in there. Now look at the next one. Again, we're going to do increasing. We're going to do decreasing. We're going to state those intervals, and then we're going to find any minimums or maximums. So I'm using my colors again. So let's look at where it's decreasing. So it's going from negative infinity, let's see, down to about this point. And then starting here, we're going down again. And so from this to this point, we've got our increasing. So I'm just kind of recognizing my areas right now, wrong color, just kind of recognizing my areas right now, and then I'm going to write my notation. So let's see, it's increasing from negative 1 to 1 using those x values, and then it's decreasing from negative infinity to negative 1, union with 1 to infinity. Now if we go in here, we start taking about local minimums and maximums, we can see we're going to have a point here and a point here where we're changing colors there. And so we would say there is a local max of, again, you're going to take this y value, 2 at x equals 1, and there's a local minimum of, again, we're going to take this y value here, negative 2 at x equals negative 1. So I hope this is making a little bit more sense of those definitions where we ended in the first video. Last one. So let's see, decreasing, we're looking at decreasing from here to here, and then here to here, and then note that this is not a arrow. So we're going to have like a closed off interval here, closed interval. And then we have increasing here, and we have increasing here. And so we would say, where is this function increasing and decreasing? Just keeping with my colors here. So we've got yellow, we've got green. So let's see, increasing, that's kind of in the middle there. So we're going to say, get my colors in here. So we're going to say negative 2.5 to negative 2. And we're going to union that with 0 to 2. And then where is this function decreasing? Negative 2 to 0. And then from 2, union, from 2 until we get to 3. So this one was on a closed interval. Now here's the interesting story with this one. When we're looking at our minimums and maximums, our minimums are going to occur here where it was changing. Our maximum's going to occur here and here. But you also kind of have to take note of what's going on in some other place. So let's kind of write this out. So we're going to have a local max of 16 at x equals negative 2 and x equals 2. so at -2, and then of 16 at 2, because those high points are horizontally aligned. And then we're going to have a local min of 0 at 0. And there's our maximum and minimum points. Now, with this closed interval, the book goes furthermore and says that they consider these 2 points to also be minimum because they are the lowest y values of the points that are near them. So that's kind of the added thing that I wanted to add on this one, is that you continue to have a minimum at 12, a minimum of 12 at -2.5, and then you also have a minimum of, let's see, is it all the way at -12? That looks about -10, so of -10 at 3. And so that was kind of an interesting thing on that closed interval that I wanted to throw in there. So with all of these examples, we're looking at finding increasing and decreasing. We're looking at minimums and maximum, and then getting our wording, notation, and intervals correct. Now there is one in your homework that I thought you would want to cover here. And this one says, given f of x of 1 over x plus 11, find the average rate of change of f of x on the interval from 5 to 5 plus h. And so I want to make sure I kind of threw in another example for you, because I know it can be a little bit more difficult working with these values such as an h. But I want to show you how this all works out. I'm also going to show you a little bit of fraction tricks as we work with this. So kind of hold tight, but this is going to aid you as you work in the homework. So first of all, let's recap. If we're looking at average rate of change, we're looking at slope. So we're looking at m being equal to f of x2 minus f of x1 all over x2 minus x1. So the first thing I need to do is I need to grab all those values. So remember, this is an interval notation, so this is going to be your x1, it's going to be your x2. So I'm going to say f of 5 is equal to, and we're plugging into this function here. I'll write it larger for you. F of x is equal to 1 over x plus 11. So I'm going to plug 5 into that. So that's going to be 1 over 5 plus 11, which is 1 over 16. So that's going to be my f of x1. Then I also want to 5, and if you like that as an order pair, we can say 5 comma 1 over 16. And then I would find f of 5 plus h. So that means I'm going to write my function, and everywhere I have an x, I'm going to plug in 5 plus h. Now simplifying that up, the 5 and 11 will still go together, so it gives me 1 over 16 plus h. And this is kind of alluding to something that we're going to do as we progress and as we also move into our another course, so I want to make sure that I threw that in here. So this order pair would be 5 plus h, comma, 1 over 16 plus h. So whether you like the way it looks or not, you just got to follow your processes and follow your steps and keep doing what you know how to do. So now you've got your x1 and your f of x1, or y1 if you like. You have your x2 and your f of x2, and so I'm going to come down here and I'm going to plug that into my average rate of change equation. And so that would be 1 over 16 plus h minus 1 over 16, and then that would be 5 plus h minus 5. Now I want to show you something, kind of a little side note here. Whenever you're working with fractions, obviously, you know, your scientific calculator can help you with fractions, but it can't really help you with these h values. So let me show you a little fraction trick if you aren't aware. If you have a plus b, a over b plus or minus c over d, meaning if you're adding or you're subtracting fractions, it doesn't matter. You can do a little trick to help you with this and to go faster. What you do is, you multiply this way, and that would be AD. Whatever your sign is, either positive or negative, you multiply this way, and that would be your BC. All over, you multiply across the bottom, BD. And this is a really nice way to combine your fraction. In middle school, you learn how to find common denominators, and all that's really great. But as you move into pre-cal and calculus, you're working with more variables, it's really harder to find common denominators between 16 plus h and 16. And so we need some kind of fraction trick to help us with that. And so I'm going to do that fraction trick here. So I'm going to multiply this way, and I'm going to do 1 times 16. And 1 times 16 gives me, I'm going to go beneath here, 16. Then I'm going to multiply this way. 16 plus h times 1, we're subtracting, so I'm going to bring the minus sign from the problem. And 16 plus h times 1 is just 16 plus h. All over, I'm going to multiply this way. So that gives me 16 times 16 plus h. Now when we're working this whole thing was over, let's see, 5 plus h minus 5. So those 5s are just canceling. So we're just over h. Now that looks crazy. Look at all those fractions. But let's kind of clean this up and see what's going on. So let's see. The 16 and then negative 16 are going to cancel. Now don't forget, you need to change all your signs. And so 16 and negative 16 cancel. And that gives me a negative h over 16 times 16 plus h, all over h. And then if you remember your rules of fractions when you're dividing, because essentially I have this fraction divided by h, I'm going to write that horizontally and that'll help. So I have this divided by h. Remember, you keep it, change it, flip it. So you keep the first, you change it to multiplication, and you flip the second. Now when you multiply fractions, you multiply across the top, so that gives you negative h, over multiply across the bottom, and that would give me 16 times 16 plus h times h, and these h's would cancel. Now when you go to cancel on the top and bottom, don't do bad math. You can only cancel when you have multiplication or just a single term. So because this is all being multiplied, and because I only have a single term in the top, I can cancel these h's, and then I definitely don't want to forget my negative along the way. And so this would be my final answer. Now, whether you like that or not, working with fractions is a lower technique of being add, subtract, multiply, and divide. So for this problem, let's kind of recap. Working through all of this was just algebra and cleaning this up. The pre-cal of it, of the concept we're reviewing, is how to find average rate of change. And the pre-cal of it that we're trying to figure out is the average rate of change of 5 to 5 plus 8, just h units away, and what that looks like. And what this is going to do is this is going to help us as we move forward and we discover more content, especially as this course, it is a prereq for calculus, and it helps you to move into that. So I just want to kind of come on here and create another kind of part B to 1.3 and kind of go through some of these specific problems. But as always, if you need any help or you have any questions, comments, or concern, feel free to reach out to me.